Medicanes, unraveling the mysteries of Mediterranean hurricanes. In the realm of meteorology, certain phenomena defy expectations and challenge our understanding of the natural world. One such phenomenon is the Mediterranean hurricane, affectionately known as the Medicane. While these cyclones are smaller in scale than their tropical counterparts, they pack a punch and leave an indelible mark on the Mediterranean region. In this comprehensive exploration, we delve into the captivating world of Medicanes, uncovering their characteristics, impacts, origins, and the dedicated researchers who have unraveled their mysteries. Introduction to Medicanes. Medicanes, short for Mediterranean hurricanes, are mesoscale cyclones that manifest in the Mediterranean Sea. These cyclones are distinct from their larger tropical cousins but share several key features during their mature stage. Characterized by a quasi-cloud-free calm eye at their center, spiral-like cloud bands extending from the core, strong winds near the vortex center, and a deep, warm core, Medicanes exhibit tropical-like features that have fascinated meteorologists for decades.
The main consequence can be a strong confusion in the public opinion, but it's likely that the use of term Medicane or Mediterranean hurricane is more effective in capturing the public attention than a more general term like Mediterranean cyclones. With the ongoing climate change, it is becoming also quite widespread, the idea of the tropicalization of the Mediterranean area. However, Medicanes are a specific type of cyclones which at some point during their evolution undergo a tropical-like transition, exhibiting a feature similar to cyclones occurring in the tropics or subtropics. Medicanes are severe events which have been studied more in depth in the last years, but they are not a recent phenomenon. The availability of the first satellite measurements revealed their occurrence, but the latest observation and the modeling advancement allowed a more detailed characterization of this phenomena. The scientific community is working hard to provide a unique definition of Medicane, but it's not an easy task because of their rare occurrence and their short lifetime, usually just a few days. Basically, the Medicanes are sustained by the energy transferred from the warm sea to the atmosphere, but the smaller size and the lower sea temperature of the Mediterranean basin with respect to the ocean do not allow the long-lasting cyclones with the tropical-like characteristics. In addition, a Medicane, I would say a cyclone in general, is not a static phenomenon, but during its lifetime it undergoes different stages from an initiation to a deepening phase up to the mature stage, when most of them show characteristics similar to the tropical cyclones. This does not mean, for instance, that every system showing a strong cyclonic circulation has to be labeled as a Medicane. And at the same time, a cyclone which does not reach a tropical-like phase is not necessarily weaker or less dangerous and destructive than a Medicane. To make an example, the first analysis on the cyclone Daniel occurred only a few days ago seemed to not show tropical-like features during most of its evolution, both during its intense phase of devastation over Greece and during its transition over the Ionian Sea. But it lasted several days, gaining energy from the warm Mediterranean Sea, and there are some indications that it may have become a Medicane only in the last phase of its evolution, right when it was approaching the coasts of Libya. When it has made a landfall, the strong winds, precipitation and storm surges have contributed to the devastation that we have seen. but we need additional and deeper analysis to clearly define its evolution. And within the MedCyclone cost action CA 19019, there is a dedicated activity on the characterization and definition of Medicanes. And together with Dr. Panegrossi and the other members of the satellite meteorology team at the CNR ISAC Institute in Rome, we are studying how the satellite observation can be used to characterize these cyclones and determine their transition to Medicanes.
Key characteristics of Medicanes. Let's dive deeper into the defining features of Medicanes. The eye of tranquility. At the heart of a Medicane lies a serene and nearly cloud-free eye, a hallmark of mature tropical cyclones. This calm center is surrounded by intense convection, creating a striking visual contrast. Spiral cloud bands. Medicanes are known for their spiral-like cloud bands that stretch outward from the central eye. These bands can extend over hundreds of kilometers and are responsible for the cyclone's heavy rainfall. Intense winds. Close to the vortex center, Medicanes unleash powerful winds that can reach speeds of 190 kilometers per hour. These winds contribute to their destructive potential. The warm core. One of the most intriguing aspects of Medicanes is their warm core, a feature shared with tropical cyclones. This warm core extends from the lower to the upper troposphere and plays a crucial role in their development.
The main tool we use to observe and study the Medicanes are the satellite data. In particular, we consider the microwave frequencies to provide both a thermodynamical and microphysical characterization of Medicanes. The sensor exploiting the microwave measurements are passive microwave radiometers on board the LEO satellite. LEO is the acronym for Low Earth Orbit and refers to satellite flying around an altitude of 700-800 kilometers, mainly on polar orbits, so traveling the Earth from north to south and passing each region in the globe a few times per day, depending on the latitude. The passive microwave radiometers measures the upwelling radiation emitted by the Earth that interacts with the liquid and solid precipitation particles, the hydrometers, within the cloud. This means that from their measurements we are able to infer the vertical structure of cloud and precipitation. Some microwave channels are used for temperature and water vapor vertical sounding, also in presence of clouds, and by exploiting these measurements we can infer the presence of warm core by analyzing the temperature anomaly field, the presence of deep convection, and characterize the microphysical structures of cloud and precipitation, such as rain bands and the cloud-free calm eye. The LEO satellites do not provide a continuous observation of the same region, but have a revisiting time depending on the orbit and on the width of the sensor swap. In addition, the spatial resolution of microwave frequencies is not so high, and this is an issue to account for. In fact, the Medicanes have small sides, especially if compared to the hurricanes, and the warm core or the deep convective cores could have comparable sides or even smaller sides than the instrument resolution. Other sensors working at the infrared or visible frequencies can provide higher spatial and temporal resolutions since they are also available on geostationary satellites, but they do not have the same capabilities of microwave in characterizing the clouds and the precipitation. A significant improvement on this aspect could derive from the new generation of LEO satellites, which will be launched in the next years, or like the NASA Tropics mission, which has been launched recently, but which will cover only the southern Mediterranean region, or the upcoming European EPS second generation satellites. This will bring the availability of more measurements with higher spatial resolutions, thanks to the technological advancement with which the new sensors are built.
Key research papers and notable scientists. Understanding Medicanes has been a journey marked by significant research contributions. Here are some key papers and the scientists behind them. In a seminal 1999 paper, Laguvardos and a team of researchers laid the foundation for our understanding of Medicanes, particularly their tropical-like characteristics during the mature stage. Milieta's research, especially in two papers published in 2013 and 2015, has played a pivotal role in unraveling the mysteries of Medicanes. His work has provided valuable insights into their characteristics and behavior throughout their life cycle. Research published by Milieta and Rotuno in 2019 explored the development and intensification mechanisms of Medicanes. Their work contributes to the ongoing debate about whether Medicanes can be considered purely diabatic systems like tropical cyclones. In 2022, D'Adderio and a group of researchers employed GPM-CO observations to analyze the evolution of precipitation structures during the development and mature phases of Medicane Llanos, shedding light on the storm's inner workings. Finally, Panagrossi and a team of researchers presented a pioneering investigation using passive microwave data to unravel the intricate relationship between warm cores and deep convection in Medicanes, shedding new light on these Mediterranean cyclones. This research by Panagrossi and her team offers valuable insights into the inner workings of Medicanes, highlighting the critical role of warm cores and deep convection in their formation and intensification. Leveraging advanced microwave-based techniques, this study contributes to our understanding of Medicanes, providing essential knowledge for improved forecasting and risk assessment in the Mediterranean region. Size and impact of Medicanes. Although Medicanes are smaller in scale compared to their tropical counterparts, they are by no means insignificant. These cyclones typically have a diameter ranging from 100 to 300 kilometers, which can span across entire coastal regions. Their impact is far-reaching and includes heavy rainfall and flooding. Medicanes often bring copious amounts of rain, leading to widespread flooding in affected areas. The combination of intense precipitation and hilly terrain in the Mediterranean can result in devastating flash floods and landslides. Intense winds. The strong winds near the core of Medicanes can cause significant damage to buildings, infrastructure, and vegetation. Coastal areas are particularly vulnerable to wind-driven storm surges and high waves. Storm surges. Medicanes can generate storm surges that inundate coastal areas, posing a significant threat to coastal communities. Disruption of transportation. High winds and heavy rainfall can disrupt transportation networks including roads, railways, and airports, making it challenging for residents to evacuate or receive assistance.
As highlighted before, the Medicanes are relatively small systems. This means that with the current available measurements, the identification of their characteristics could be not easy, at least from observational point of view. Furthermore, their origin is topic of discussion and study. In fact, often they originate from a cutoff flow of extratropical depression, maybe related to the intrusion of warm air from the stratosphere. An essential element is a source of energy to maintain and even reinforce the cyclone. This is represented by relatively warm sea compared to the upper troposphere and release of latent heat due to the convection around the cyclone center. A Medicane can develop and live only over sea where the diabatic forcing is the main energy source to convert a cyclone in Medicane. Know if the diabatic forcing is prevailing on other forcing or if it is the only one, so to allow the development of purely barotropic structure is something that satellite data are helping in understanding, thanks to their capability to reconstruct the Medicane's thermodynamical vertical structure. The next step is to link the model output to the satellite data. In addition, the estimation of medical intensity is challenging due to the lack of ground-based reference data overseas. And there are different algorithms that estimate the tropical cyclone intensity, and that could be adapted to the medical with a bit of work. But their development was possible thanks to the availability of reference data collected from airplane measurements during dedicated flights taking place when an event, an hurricane, occurs. These measurements lack in the Mediterranean region, and this gap has to be filled if we want a complete characterization of the Medicanes.
The ephemeral tropical-like phase. One of the most intriguing aspects of Medicanes is their relatively short-lived tropical-like phase. This phase, characterized by a warm core, typically lasts only a few hours during the mature stage of the cyclone. The warm core extends from the lower to the upper troposphere and is a result of the release of latent heat due to convection around the cyclone's central pressure minimum. This phenomenon, observed by, among others, Lagovardos and his team in 1999, is a key indicator of the tropical-like nature of Medicanes. Frequency and origins of Medicanes. Medicanes are generally considered rare events in the Mediterranean region. Several studies have attempted to assess their frequency using both models and observations. In 2014, Caviccia and a team of researchers conducted a comprehensive study, estimating an occurrence rate of approximately 1.5 Medicanes per year, with variations across seasons. Researchers have also explored the origins of Medicanes, which often involve a combination of extratropical and tropical cyclone theories. Satellite insights and recent developments. In recent years, advances in satellite technology have revolutionized our ability to study Medicanes. Instruments like the Global Precipitation Measurement Mission, introduced by Howe and a team of researchers in 2014, and by Skowronek-Jackson and a team of researchers in 2017, have played a pivotal role in monitoring the development and evolution of Medicanes. These satellites employ microwave and radar measurements to capture data on precipitation patterns and cyclone dynamics, offering invaluable insights into these unique weather phenomena.
The results obtained by the satellite and observational in general analysis are threefold. If on one hand they can be used to verify the model forecast, for example, we can verify the track of the cyclone or the precipitation estimation. On the other hand, they can provide new and additional insights on microphysics and dynamic processes for a better development of the model, basically to improve the parameterization. This is even more true in the case of Medicanes, since they are events occurring overseas where the ground-based measurements are rare or not available. In addition, the satellite data can be assimilated within a model to improve the forecast. And our modeler colleagues obtained a significant improvement in the forecast of the precipitation field associated to Medicane NUMA, assimilating satellite parameters like spaceborne radar reflectivity. Medicanes are a rapid evolving system, and in these cases the data assimilation has a greater impact on the forecast. At the same time, the forecast improvement is effective only for the first few hours following the data assimilation. Therefore, the higher the availability of satellite overpasses, the better the model performance thanks to the data assimilation. As said, the verification of the model output is another key point. With satellite data, we can check the track of the cyclone, characterize the thermodynamical, such as the presence of warm core, and the microphysical properties of the system, and estimate the wind and the precipitation intensity. These aspects are fundamental settings and outputs at the same time of a numerical weather prediction model that make the observation verification a key contribution to continue in improving our ability to correctly predict the evolution of these cyclones.
Record-breaking Medicanes. One of the most noteworthy Medicanes in recent history was Medicanes, which formed in September 2020. In 2022, Laguvardas and a team identified Janos as the most intense Medicane ever recorded. It made landfall in Greece, unleashing its fury with strong winds and record-breaking daily accumulated rainfall. Ongoing research and the Medicane puzzle. Researchers continue to study Medicanes using satellite observations and sophisticated models. Their goal is to unlock the remaining mysteries surrounding these unique cyclones. By gaining a deeper understanding of their development, structure, and behavior, scientists aim to improve our ability to predict and mitigate the impacts of Medicanes in the future. In conclusion, Medicanes are captivating and relatively rare meteorological phenomena that add a touch of tropical flair to the Mediterranean region. Despite their smaller scale compared to tropical hurricanes, their impact can be significant, making them a subject of ongoing scientific exploration. Through the dedicated efforts of researchers and the remarkable advances in satellite technology, we continue to unravel the complexities of these Mediterranean mini-hurricanes. Each discovery brings us one step closer to understanding and mitigating the unique challenges posed by Medicanes to the communities they affect.
This is not an easy question to answer, especially for researchers like us which work on observational data. I want to recall that the satellite measurements, the microwave satellite measurements are available from the 17th, but only from the end of the 19th the instrument spatial resolution became fine enough to see this phenomena. I can say that the first passive microwave sensor useful to the study of Medicanes was on board of a NOAA 15 satellite launched in May 1998. If we consider this as starting point, we do not have more than 25 years of data. Currently, we are carrying on an activity on a longer dataset going back until to the year 2000. Starting from a list of potential Medicanes derived from numerical model outputs, the aim is to provide a thermodynamical and microphysical characterization from satellite measurements of these cyclones in order to shed a light on their possible tropical-like features. This could give us an idea about a temporal trend in the occurrence of this phenomenon, even if the period is too short to have a climatological classification, or to say if the ongoing climate changes can have an impact on this trend. Some theoretical studies do not predict an increase in number of Medicanes occurrence, but an increase of the intensity. We will be here to verify this and to help with our analysis and better definition of possible future scenarios. Meanwhile, the alert system can be improved, taking advantage of the increasing volume of data available, which allowed to monitor this system in near real time, and together with the numerical weather prediction models to prepare the population and the competent authority to face the effects of extreme events like strong winds, intense precipitation, storm surges associated to this system. The idea to develop something close to an operating chain came up within the MedCyclone cost action. What we are working on is to merge the information coming from model simulations of potential Medicane with the satellite data. Basically, the model outputs are going to be considered as input to perform a specific analysis on satellite data to describe the characteristics and try to quantify the strength of a Mediterranean cyclone. This will be done in real time or near real time, that is, as soon as the satellite data will be available. It's not an easy work considering the short lifetime of Medicanes and that we have to connect different sources of data, but we are working hard on it.